Azure Cosmos DB live TV. Back at you again. Hope you didn't miss me too bad last week while I took a week off. Took the family down to San Diego and we checked out the San Diego Zoo and then drove up 30 minutes to go check out their safari park as well. So nice, and it was actually quite hot down there. Thomas, how are you? Sorry, I should say welcome, Thomas. How are you?
I'm great. Thanks, Mark, and hi, everyone.
Yeah, good to see you again. Yeah, it was hot last week down there, especially at the safari park. It's located in just outside Escondido, which is, I don't know, about 15 miles off the coast there. It's probably in the 90s there.
Oh, nice.
Yeah, so I was looking for shade the whole time. Yeah, it was a lot of fun seeing lots of great animals. San Diego Zoo is just amazing. And if you haven't been, I guess I'm now plugging an ad for the San Diego Zoo. It's actually a pretty cool place. Anyway, welcome everyone. This week, we're going to talk about a relatively new feature. I think we've only been talking about it for maybe just less than a year. And that's client-side encryption. So I've got Thomas back again. And Thomas was with us back in our Build Roundup show in May, where he talked briefly, I guess, about client-side encryption, which we announced it's GA now, correct, Thomas?
No, we are still public preview on that feature.
Okay. So we're still public preview. I can't keep anything straight. We've got so many features.
Yes.
I need a spread. I need to make a spreadsheet of this stuff.
Yeah. What when GA at build is the role-based access control.
That's right. Okay. Yeah. That's what I'm getting confused on. You work on so many different features. I can't keep your features straight.
I'm confused as well.
Yeah, that's good. I'm glad I'm not alone. So let's talk about this, the client-side encryption. Question I have is, another feature you worked on was the customer managed keys, right? So and for those that don't know, Cosmos encrypts data both in transit, of course, and at rest, right? And we have Microsoft managed keys that do that. So your data is always encrypted. And then I guess earlier this year, was it at Winter Ignite, we GA'd customer managed keys? Was that right?
So it was even earlier than that. I think that thing went live early 2019.
Oh, was it? Okay.
Yeah.
So customers could use their own key out of Key Vault and encrypt the data using their own key. So basically, they would encrypt our encrypted data, right? So you're double encrypting it.
Right.
Now you got this client-side encryption. So I guess, why would I use that? I guess I'm curious, and I'm sure others are as well, our viewers here. What's the use case for using client-side encryption?
Yeah, I think that's a great question to start with, because our users may be a bit confused by all those different flavors of encryption they can play with when working with Cosmos DB, right? So as you mentioned, what we have launched a while ago and the full name of what we launched was Encryption at Rest with Customer Managed Keys. Okay? And as you just mentioned, Cosmos DB always encrypts the data. Right? By default, there is no way to use Cosmos DB in an unsecure fashion. Encryption in flight is always there. TLS 1.2, we can't disable it. And also, whenever we write user data on our disks, the data also gets encrypted by default. And again, something that cannot be disabled. Now, what's happening by default is that encryption is controlled by encryption keys that we manage, that Microsoft manages, and we follow the usual security life cycles of managing those keys and rotating them and applying all the best practices. And that's basically the promise of the cloud, right? You don't have to care about those things because we run infrastructure for you, and we make sure that you are secure by default. Now, what the additional capability that we introduced with encryption at rest with customer managed keys is giving our customers the ability to control that encryption that is happening server-side, right? An encryption that they never really see because it's an encryption that happens before the data gets written on our disks. So we gave them a way to control that encryption with keys that they manage, customer managed keys. I mean, the name is fairly well chosen, I guess. And the situations where our customers pick that capability it's kind of niche, right? Because most likely customers want to have that control because this is mandated by regulations from the industries or the verticals they're operating in. Right?
Makes sense. And everybody knows that regulatory policies always are common sense driven, right? So
right, absolutely, yeah. So sometimes they are just mandated that they need to, have the control over the encryption key that eventually controls that encryption, that even if it's happening in our infrastructure. Right? And so even when using that CMK, that custom managed key, customers still never see the encrypted data, right? Because everything happens transparently on the back end, and whenever they read back the data, it is automatically and transparently decrypted. So, and again, the real use case here is to comply with regulations. So that's very different from the feature we are talking about today. So the shiny name of the feature is always encrypted, and we have borrowed that name from our SQL friends. So always encrypted is a concept that has been existing on the SQL side, I think, for more than 5 years now. They've introduced that 2015, 2016, a while back. And not only have we borrowed the name, but we have also borrowed the underlying concepts. And we wouldn't have named it the same if it wasn't actually the same approach. So always encrypted is really client-side encryption, so very different from what I just explained. So it is an encryption that is completely happening application side, right? It's happening on the client in the context of the Cosmos DB SDK. Now, the scenarios where you want to use always encrypted. So to put that in context, this is just another step in our journey to make Cosmos DB more secure and to expose more security controls to our customers. And there are specific scenarios where you want to have that extra coat of encryption and protection on some parts of your data. Right? So what always encrypted and what that client-side encryption lets you do is to specifically encrypt some properties within those JSON documents that you write to Cosmos DB. And so we will cover that in detail in a little sample that I have prepared here. But the idea is that if you have specific properties, or you could call them columns, for our viewers who are coming from a relational background, so specific properties in your data set that require extra attention because those are sensitive properties in terms of the data they represent. Then you can again code them with another layer of protection by specifically encrypting them client-side.
Didn't SQL have a feature called, was it masking or something like that? That you
right. Yeah.
So this would be, is this similar in that regard?
It is similar in that you can probably achieve the same goals and the same requirements. It is different in that, strictly speaking, masking is not encryption. Masking is either making some fields disappear, so not making sure that some fields are just not exposed.
Like a password or something like that,
right?
Yeah.
Sometimes masking just transforms the value on the fly so that an email address still looks like an email address, but it's not the original data.
Okay.
So to some extent, client-side encryption lets you do similar goals in that if you have specific properties in a data set that you don't want anyone to be able to look at, then obviously by encrypting them, you can reach that requirement.
Interesting. Okay. So you could have, using client-side encryption, I guess if you also enabled CMK, you could encrypt your data 3 times.
Absolutely. This is triple encryption. Definitely. Yeah.
So
I've never seen triple encryption as a requirement in any kind of compliance or regulation. Usually, some industries have requirements for double encryption, which is pretty common. Triple encryption, we are not there yet, but well, Cosmos DB can already do it.
Hey, you know what? I say don't ever underestimate government agencies to come up with.
Yeah, but we are there. We are ready to.
But when they do, they say you need triple encrypted. We're there for you.
Absolutely. And I think one thing to understand, one very strong guarantee that client-side encryption brings, and that's just impossible to achieve, in any other way, is that when you use client-side encryption, well, first, Cosmos DB, the service Cosmos DB, will never ever see the unencrypted data, right? Because it is encrypted in your application. So when it leaves your application, it is already encrypted with the keys you have created. And again, we'll come to the process in a moment. So not only Cosmos DB, the service, never sees that sensitive data in plain text, but even on top of that, we never see the encryption keys that were used in order to encrypt that data. Okay? So this pushes very, very far the guarantee that there is no way for Microsoft to see what that original sensitive data was.
So let me ask you a question then. If we don't see the data, how do we execute a query server side?
Well, we'll come back to that in a moment. Obviously, you have a good intuition there in that operating queries on encrypted data, is challenging, and as it is today, we don't let you perform the full range of query capabilities that Cosmos DB can do. We already support a small subset of queries. We support equality queries on encrypted data. Anything beyond equality queries actually would require us to operate in some kind of confidential computing environment. And this is, by the way, what our secret friends have done, right? They have that concept of secure enclaves that you can attach to your application, and that enclave lets you run a broader scope of query constructs over encrypted data. So we are not there yet. We haven't fully completed that arc. We are obviously actively working on that. But yeah, bit by bit, we will expand more and more what you can do over data that you have encrypted client side.
Okay, cool.
Yeah.
Well, I'm looking. I want to see some more. So
let's do this. Yeah.
We get to some demos here. So let's see. I think we got you in there.
Yeah, I prepared a little sample use case to see the feature in action. Okay. And so the example, the kind of real world example we are going to look at is a HR, human resources application where we want to store employee information in Cosmos DB. Yeah. So the usual suspects: the first name, last name, which department is that particular employee working in, but also some information that you could consider as sensitive, right? Salary information, depending on your company's policy, this is something that probably you don't want anyone to have access to. Social security numbers, this is something that is extremely sensitive, and any leak of social security numbers would be extremely damageable. So here you have that data set with some data that is very common and some data that requires extra attention and that we should probably protect a bit better, right? And so in terms of, let's call it access control, probably what we want to do is to make sure that, well, everyone can have access to the common fields, right? Maybe you want to run some kind of employee directory on top of that data set, and so it's just right through to let anyone look up whoever is working in the company. But only that, right? Salary and social security numbers should be somehow hidden from anyone. And then we would have a second layer, which is the HR staff. So people working in the HR department, and those people, they need to have access to salary information in order to to fill their duties. So they should have access to that additional property. And then just to make a complete use case, I was also thinking that there is somewhere some kind of HR service, some headless application that does, I don't know, tax reporting or things like that, and that service should have access to the full thing.
Yeah, or like a payroll app or something like that.
Absolutely.
That you need,
Absolutely.
Probably their employee ID, SSN for withholdings and salary.
Absolutely.
Yeah,
absolutely. That's the context.
Yeah.
So how can we achieve that? Well, even without client-side encryption, one way you could approach that is by storing those extra properties in different documents that could sit in different collections. Okay. What you could do today with role-based access control, for example, is you could control depending on the role of the identity of the who is issuing database requests. You could route those requests to specific collections. So you could have one collection that only contains salary information, another one that only contains social security numbers. It's doable. It's extra work. It makes, I think, the overall data model a bit more complex and a bit less flexible. So what we want to achieve here is to actually really keep all the data into one collection and control that access to those sensitive properties through client-side encryption. Okay. So practically speaking, what we are going to do is that, well, first we are going to protect the salary information by encrypting it, right? So kind of obfuscating that to anyone who doesn't have access to the encryption keys. And we are going to control the encryption of that property with a key that will be stored in Azure Key Vault, in the first instance of Azure Key Vault. And then we'll do the same with the social security number. We are going to encrypt that thing with a different key, and that key will be stored in a different Azure Key Vault instance.
Oh.
And the reason, yeah.
This is interesting. I didn't realize that you could use different keys for even the same document. How many keys can you use for a document?
Yeah, good question. I think right now we have a soft limit of 20 keys per account. This is a limit that it's not a hard limit. It's a limit that is in place for the duration of the public preview. And as usual, previews are, for us the opportunity to kind of measure which limits are, the most practical for our customers. If it turns out, based on the feedback we gather during the preview that customers actually need more keys, then we will just expand that limit. Right now, I think we are at 20 keys.
20 keys. Okay.
Yeah.
Okay.
And the reason why I put those two different keys into two different Key Vault instances is because then I'm going to play with each Key Vault's access policies to make sure that we restrict the access to just the personas or the identities who should have access to that. And so what that means is that I will add the HR staff to the access policy of my Azure Key Vault 1, because the HR staff, they are allowed to read salary information, but not the social security numbers. And then I will use the identity of my HR service and use that identity into the access policies of both Key Vaults, because that's
great.
Yeah.
So you're effectively applying RBAC, basically, using this.
Yeah. Absolutely, because when I say HR staff, sorry, where is my pointer here? When I say HR staff and HR service, those are AD identities, right?
Yeah.
And so, yeah, it is very similar to role-based access control at the granularity of individual properties within your JSON document.
Yeah, cool.
So let's see that in action, right? And so let's see how we can implement that end to end. And before we jump in, there is one concept I really want to clarify for our viewers, is that concept of encryption keys. If you have never dealt with encryption on Azure or any public cloud, there are some subtleties that you should be aware of. And so let me switch to the documentation here. I'm going to scroll down, and this is essentially the thing to understand. Okay, you have to understand that for each property that you are going to encrypt, there will be not only one but two encryption keys involved. Okay. And that two-layer of keys is something that is very common. And as far as I know, most of the encryption controls that are available on Azure rely on the same model. So if we read that diagram from right to left, starting with the data. So the data that you are going to store in Cosmos DB is going to be encrypted with a first key, which is called the DEK, the data encryption key. Okay, so that's really the key that is actually used to encrypt your data. And that key is also going to be stored in Cosmos DB together with your data, because this has to remain consistent. We have to store that key together with the data that you have encrypted. And those DEKs, we are also going to create them client-side. So as I will show you in a moment, we have additional methods exposed by those new SDK extensions. And those new methods let you create DEKs. Okay? Now, remember what I said before. I said one strong guarantee that comes with always encrypted is that Microsoft Cosmos DB, we never see those plain DEKs. So there is no way for us to in any way to read back the data that you have encrypted. And in order to meet that guarantee, before those data encryption keys get stored in Cosmos DB, they are themselves encrypted with a CMK, a customer managed key. Okay? And those are the keys that our users create and store in Azure Key Vault. Okay? And so those two layers of encryption keys, as I mentioned, they bring the guarantee that whatever is stored in Cosmos DB, is encrypted. So there is no way for us to kind of reverse engineer and find out, what's the list of social security numbers. It's also let our customers implement that access control by using the access policies of Key Vault, right? By adding the right identities to each Key Vault instance, you can really control in a very fine-grained manner who has access to each of the properties that you are going to encrypt. And obviously, you have the ability to revoke those keys. So if you want to really, lock the access to a specific property, you would revoke that CMK, and that would completely lock that chain of encryption that is downstream. So in order to implement our little use case here, that I think that I just mentioned before, I'm going to switch to Visual Studio here. And here, basically, I have two projects. I have two small applications. One is going to show what, oops, I shouldn't have opened that. One is going to show what's happening in that headless HR service. So the HR service is let's say the entity that has full access to all the encrypted properties. And then I have a second program that shows what the HR staff in particular will be able to do. So we've restricted access to some of the properties. We should start with the Azure Portal, because the first step is to actually have AD identities representing each of those different entities. Okay, so I'm going to go to the Azure Portal, looking at the Azure Active Directory section of the portal, and I just wanted to show here that I, for some reason I can't scroll down. Okay, let me see. I want the devices, I want the app registrations. Oh, is it because I'm so zoomed in that I cannot scroll down? Oh, okay, interesting. So I'm sorry, I need to zoom out.
Yeah, that's okay.
Or maybe I need to close the things. Yeah, a bit better. So what I did, I created two service principles. Okay, one that represents that HR service, and another one that represents the HR staff. Now, in a real world scenario, you would probably use an AD group, to which you would add all the staff. But for the practicality of the demonstration, I'm using a service principle. Any kind of AD identity can be used here. You can use service principles, user principles, AD groups. But again, just to make it practical here, I have created two different identities representing the different entities that will interact with our data set. Now, the other thing that I have also pre-created are, this is really not Zoom friendly. I have created those two different keyboards. Okay, so just looking back at my slides, I have keyboard 1 that's going to contain the key controlling the encryption of the salary, and then keyboard 2 containing the key controlling the encryption of the SSN.
Oh, that's interesting. So you actually have to create separate, because you can store different keys in the same key vault, right?
Yeah.
But you want to use, but you can't have different access policies on them. So
absolutely.
Yeah. What you're doing.
That's the reason why you have to juggle with multiple keys.
To create multiple key vaults because you have differing access policies. Makes sense.
That's right. Okay. That's right. So if we look at my key vault number 1, here I have pre-created a CMK1. Okay, so that's the custom managed key for the first key. And if we look at the access policies, we can see here, if I can move that a little bit, both the staff and the service have been added to the access policy of that key vault. Okay, meaning that both the staff and the service will be able to retrieve the CMK and use it. Now, if I just have a brief look at the second key vault, as you would expect, that one has also a key, that's CMK number 2, which is going to control the encryption of the SSN. And then if you look at the access policies, then as you would expect, the staffing is not there. I only have the HR service because the staff will not be allowed to access the SSN. Okay?
Got it.
Yeah. So back to Visual Studio. Let's look first at my little program showing what the service is doing. Okay? And we will really start from scratch. And we will first create all the resources required for that application to run.
Do I need to register these keys with the Cosmos account when I provision it, kind of like what you do with CMK?
No, because the Cosmos DB is never going to access those keys. Okay? We, as a service, never access those keys. You access those keys client side because this is client side encryption. Yeah? Okay. And again, that's part of that guarantee that Cosmos DB will never be able to actually read back those keys and read back the encrypted data. This is all client side and all in the customer scan.
Okay.
Yeah. So one main change when using client side encryption is that you have to kind of augment your Cosmos client with encryption method. And what that thing does is that we attach what's called a Keystore Provider to the Cosmos DB instance. What that thing does, this is basically a proxy to the Keystore containing the CMK, containing those keys that will encrypt the data encryption keys. So this is a very pluggable model. Right now, we only have one variant of the Keystore Provider that is based on Azure Key Vault. But if in the future we want, and spoiler alert, we will support other kind of Keystore providers, this will be very, very straightforward to plug. So I am initializing my Keystore Provider with AAD credentials. Those are the AAD credentials for my HR service AAD application. Okay, so I'm basically passing the credentials that will let the SDK retrieve an AAD token impersonating my service. And with that, I will have access to both key vaults, because I have added that identity to the access policies of both key vaults. Okay? So this is just the slightly different way that you're going to initialize your Cosmos client in order to leverage clients and encryption. Next, we are going to create our resources. Okay? And the first thing to do, well, obviously, I'm creating a new database. I'm naming it human resources. And then in that database, I'm going to create those two data encryption keys. And just to make sure everybody is following, maybe I could switch back to the documentation here. Okay, those are the CMKs that are stored in Key Vault. And then for each of the property I want to encrypt, salary and SSN, I'm going to create corresponding data encryption keys. Okay, so again, this is an operation that is happening client side. And whenever you do that, it creates a new key, it wraps it with the CMK that you will provide, and store it in Cosmos DB. Okay? So here I'm creating the first key, I'm calling it DEK1, and I provide some additional metadata. I provide a encryption algorithm, and most importantly, I pass the key identifier of the CMK that is sitting in Key Vault. Okay? So here I'm creating DEK1 that will be protected by CMK1, and unsurprisingly, I am also creating DEK2 protected by CMK2. Okay? And those keys are stored at the database level, not the container level. Okay? And those are that's basically metadata that is stored at the database level. Once those keys have been created, then the next step is to actually create the Cosmos DB container that will contain my employee information. And this is the step where I am providing an extra client encryption policy. So we have a Fluent API here that lets you do that. And that API basically says that the property salary, and so this is kind of a JSON path kind of notation, the salary should always be encrypted with that DEK1 they've just created above. The encryption should be randomized, and I will come back to that in a moment. And here is the algorithm that we should use when encrypting that property. And similarly, we are going to encrypt the SSN with DEK2 in a deterministic fashion. Again, this will be touched on in a moment. And once I have created those two paths, I just attach those paths to my encryption policy, and I create the container.
Interesting. We exposed any of this stuff in our resource provider yet? I don't think I've seen any.
Okay. Yeah.
Not yet. Okay.
Not
because
yet.
nobody's asked me to write samples, ARM templates or bypass or CLI or anything doing any of this stuff. So
absolutely.
Okay.
It will come, actually. Yeah.
Okay. So eventually I'm going to get asked to write these samples, I guess. So,
Right. I think we have made some good progress recently with the control plane team on those topics. We know from our conversations with our SQL friends, and that's the nice thing of being a bit behind. We can leverage the 5 years of experience that SQL has had with clients and encryption. We know from what they have told us that our Azure customers and users will expect to be able to manage those keys through the control plane and not only from the data plane. Yeah.
This is quite interesting to see. So that this is the definition of the container itself requires this. So so it's quite a bit different than what I think people are used to now. Kind of using the create container syntax. So interesting.
Yep. So once I've done that,
can you what is the difference between randomized and deterministic for your encryption type?
Right. Yeah. So I will come to that in a moment. This basically defines whether the initialization vector that is used when you encrypt the property, should that thing be random or not? And so essentially the difference is that whenever you use the randomized encryption type, if you encrypt the same property multiple times, you will also come up with a different ciphertext. Okay? If I take ABC and I encrypt that thing 10 times, I will have 10 different results. Okay? Whereas with deterministic, the initialization vector is fixed. And so if I encrypt 10 times the string ABC, I will have 10 times the exact same result. And this is very important to understand, because if you want to be able to issue SQL queries that do equality filters on encrypted properties, then you have to choose the deterministic encryption type. I will cover that just below.
Oh, say that one more time.
Yeah. So actually, let's tackle that in just 5 minutes. It's just down there. I will show you a query that filters on an encrypted property, and you will see why the encryption type is essential to understand here. So just briefly, once I have done that, I have a new container that has been created with a client encryption policy, and so that container is ready to be used with client and encryption. The next thing I'm doing in my little sample here is that I'm just inserting 2 documents. Okay, 2 employees. I have Jane Doe and I have John Cosmic here, 2 employees of our fictional company, with some sample data here. So what's interesting to see is that that salary property that has been included in our client-side encryption policy, that thing is not just a single value, but this is actually this is going to be a JSON object. Okay, so we are going to see.
That's cool.
Right.
Very.
And I did that to show our viewers how we handle the encryption of complex types like objects. Okay. But the SSN.
Could you do an array?
I'm sorry?
Could you do an array?
Oh, of course. Yeah, we support arrays as well. Yes.
Okay.
Yeah. And the SSN, as expected, is just a string, right? And so I have just 2 different values here. So I am inserting those two documents, and then the last thing I'm doing in the scope of that program is to fetch back some employees. Okay? And so I'm doing that in 2 ways. First, I will be doing a point read. So I'm just going to read an individual item by ID. Okay? And if you look at that kind of code, this is nothing specific to client-side encryption, right? I didn't have to further augment my point read to make sure that the data is properly decrypted when I read it. This will just happen seamlessly and automatically.
Do I have to deserialize into a dynamic type using client-side encryption, or can I use strong types?
I use dynamic because I'm lazy, but you can deserialize it to a POCO just like you do today.
Okay.
Yeah. And then the second way I am fetching an employee is with a SQL query, okay? Because I want to fetch an employee with a specific social security number, and so this is the SQL query. So let's start from C, where the SSN equals that query variable. And here, in order to specify that query variable, I'm using another new method that we have introduced with client encryption, which is @parameter_async. And so that method essentially lets us inject the value that we want to use. Okay, so here I want to actually fetch my second employee with that SSN. So I want here to match that specific SSN. But because SSN is an encrypted property, okay, so this, and as we will see in a moment, this is going to materialize in Cosmos DB as a very opaque blurb of encrypted data. If I want to filter on that property, what we need to do client-side is to kind of pre-encrypt that value and inject that value in the query string. Yeah. And that can only work if this specific property is encrypted in a deterministic fashion.
It makes total sense now, because if it was randomized, you'd never get a hit if you were doing it.
It's randomized every time you encrypt the SSN, you get a different value, right? So there is just no way to write a query that would filter on that thing.
So I got a viewer question here related to this. Is it possible to make queries doing inequality? So like a greater than or a contains with this type of thing?
Right.
Because basically what you're saying is that it's throwing an equality match on the encrypted string.
Yes.
or the encrypted data itself. So it's not on the value itself. So could you do like a range type of thing in here? Like
Not today. Not today.
Not today. Okay.
Because that encryption doesn't preserve the order, right? So there are encryption types that are order preserving, but those are pretty weak encryption types. So that
I was going to say, if you preserved order, it'd be pretty super easy to crack the thing, right? So,
right. And you can say that deterministic encryption is a bit weaker than randomized, because if you are dealing with a property that has very few values, like a Boolean that is either true or false, you could with some efforts kind of reverse engineer the encryption of that specific property. So obviously something to keep in mind from a technical standpoint today. If your requirement is to issue equality queries on those properties, you have to use our deterministic encryption.
This isn't unique to us. You can't just, no matter what, basically. You can't do a range query using on an encrypted field.
No, not today. Not today. We are working on that, right? And so, as I mentioned at the beginning, our SQL friends, they have tackled that problem with secure enclaves. Okay, so, but secure enclaves is a pretty complex solution in that it requires the service to run part of the query engine in those secure enclaves. It's more set up from the client to securely upload the keys to the enclave. So you can do more with SQL today. They let you do, I believe, range queries and more elaborate queries on encrypted data. Again, we are not there yet. This is still pretty fresh, and we are just in the public preview stage of that new feature. But we are hearing loud and clear from our users that eventually they want to be able to issue a wider range of query types on the encrypted data, and so this will come with time.
Is this secure enclaves? Is this some kind of like encrypted compute platform environment?
Yeah.
Okay.
Right. Definitely.
So there, you're saying the data would be exposed, unencrypted, but the environment itself is encrypted. So
right, because at the end of the day, things like range queries, they can only run on plain text data. You can't run a range query on encrypted data. So what SQL has done with the enclaves is that they, as far as I know, and I'm not a SQL expert by all means, but part of the data gets decrypted in the enclave, and in that enclave they run a subset of their query engine, and so that's how they can actually deliver those query capabilities. But there are obviously some restrictions also going on what you can do, what you cannot do. And again, it's just additional setup because you have to connect to the enclave from the client in order to upload those encryption keys securely to the enclave. So only the enclave will know, the encryption key that will be able to decrypt the data. But because it is basically a cryptographic kind of container, there are very strong guarantees that nothing can leak out of the enclave.
Yeah, right. Interesting. Okay.
So let me run that actually. Hoping that demo gods are with us today. Here we go. Give it some time to warm up. Going to hit my first break.
So I saw you had a new package there, Cosmos.encryption. So basically, this is a whole new Cosmos client behind the scenes. Is that?
It is. Yeah, it is an extension to the existing Cosmos client.
Okay.
Actually, if I go back to my Resource Explorer here, if we look at my dependencies, I have a dependency with Microsoft Azure Cosmos.encryption, which is still in preview. And that thing, when you pull that package, then it pulls the Cosmos SDK just here. Yeah. So I have hit my first breakpoint, meaning that did I? I believe I did. Oh wait, I am in the wrong program. Here we go. I hit the first breakpoint, so I'm ready to go. The SDK has been initialized, so let's continue and let's create my container and the corresponding encryption keys. I'm using the local emulator, by the way, which is very convenient here. So if I go back to my emulator here, I refresh, I say I refresh, and okay, I have now my, maybe I should zoom out a little bit. I have my human resources database. In the database, I have an employees container, and that container is containing my client encryption policy. So now whenever I use that container from my Cosmos DB SDK, data will be automatically encrypted and decrypted. So we can go on, and I can insert those two example items. There we go. So now if you look at the items, here we go. I have my two employees with the data you would expect. You have the first name, last name, department. But then when you look at the salary, you see that stuff has been automatically been encrypted, and same for the SSL. Oh wait,
actually, it doesn't encrypt the attributes inside.
It does not. Yeah. So the approach we have taken when encrypting complex types is that, for example, for a JSON object like this one, we only encrypt the leaf values. Yeah.
Okay.
And we do that so you can actually dot into. You can still write a query that says salary.base equal, blah blah blah. As long as you have it. Yeah.
Makes sense.
Right. And the same would go for a JSON array. You would see that every entry of the array has been encrypted independently. But we have preserved that it's still an array, so we still keep the shape of the JSON object, so that you would expect if you encrypt an array with 10 entries, you still have an array with 10 entries, and each of the entries will be encrypted. Yeah.
Okay, but you only need to define the property, the salary property itself. You don't have to define any of the child.
Right.
Okay, that's cool.
And we have made sure that we still honor the schema fluidity of Cosmos DB, meaning that if I were to write another object, another document where salary is, let's say, a number or a string, that would just work, right? You can continue using Cosmos DB as you do today with no specific schema on your container, and with different documents matching different schemas.
I got it. I got a question from a viewer here. What's the performance impact for using client-side encryption?
That's an excellent question, actually. So different things to look at here. The server-side performance, so the performance of Cosmos DB as a service is not impacted at all, because actually here in that situation, Cosmos DB, the service, again, doesn't really know that I'm using encryption, okay? Because we are just, this is, at the end of the day, this is just a string, right? So this is received as a string. Most of the work is done client-side. The only little changes we have done in the backend is the ability to store those encryption keys and to store that client encryption policy with your container. But we have just added storage capabilities.
I guess it increases the payload size potentially, so that
but that would in no way affect our SLAs. Okay? The SLAs are completely covered by the service. Now there are some performance impacts to consider on the client side. And the most important one to look at is just that your application is going to consume slightly more CPU, because we are going to encrypt and decrypt on the fly. So there will be an obvious overhead. We have done everything we could in order to optimize that to the maximum. So I would say that overhead should be minimum. I don't know if minimal is a good word, but we have made sure that overhead is manageable, and it's not like we are going to double the CPU required for your application.
CPUs have gotten so good.
Yeah.
That I don't see, like it used to be, like when I was a young strapping software engineer.
Yeah.
Pentium like era of CPUs. Doing encryption client side was expensive, right? And you would mostly impact. I don't think today you're going to notice anything, frankly.
Right.
So just CPUs are just too good.
I agree.
Yeah.
And those CPUs have been very much optimized for things like encryption, right? So the other thing to take into account is that the underlying encryption library that we use is the same as SQL. So we are now sharing core libraries between SQL and Cosmos DB, which is something that we are very proud of. And it's a nice showcase of strong teams working together. But my point here is that we are also leveraging the extensive experience that SQL has put into client-side encryption for the past 5 years, and you can rest assured that those libraries have been optimized to make sure that the CPU overhead is as low as we could make it.
I always like to say, just why invent it if someone else has already done it and tested it?
Yeah.
Right. So get you to market quicker.
Absolutely.
Right? So yeah, it makes no sense to reinvent that kind of wheel. So
we have definitely factorized the efforts here. So there is a CPU hit. That's probably the main thing that you will notice. There is obviously also a dependency with Key Vault, because from time to time we are going to ping Key Vault in order to unwrap again your data encryption key. But this is not done for every request, right? That's also a good point to bring, and then I can make a quick segue on that. If I go back, actually, I'm just here. That DEK, that thing is going to live in memory in your application, client side. Okay? We can't afford decrypting the DEK every time we need to access it. First, because the performance impact would be unmanageable, but also because Key Vault would throttle us very quickly. So if you have a high traffic kind of application, that's just not doable. So we unwrap the DEK from the CMK you have stored in Key Vault at the beginning, the first time we used the key, and then we use that key in memory. We keep it in memory. It's cached somewhere in memory with a time to live that is configurable. I think the default is 2 hours, meaning that if I let my application run for more than 2 hours, that TTL will expire, and then we will reload the DEK from Cosmos DB and re-decrypt it through Key Vault. So there are some additional network calls, but again, most probably you won't have a very large number of data encryption keys anyway. And by tweaking the TTL, you can probably reach a good compromise between how comfortable you are having stale keys in memory and how aggressively you want to connect to Key Vault.
Well, so interesting. The question I had is, what happens if you rotate your encryption keys? What happens there?
So rotation of the CMK just means that we are going to decrypt the DEK and re-encrypt it with a new CMK. Okay, we are not touching the data. The rotation of the CMK, which is, by the way, something that is completely supported, and that is documented here below. Rotation of the CMK only touches the DEK. Okay, so if you are running your application and you have some other process that rotates the CMK at some point, this is going to work, transparently, because your application that is using the DEK at some point will need to reload the DEK because it will have expired, from the cached version it has in memory. And once it will reload the DEK, assuming the application still has access to the Key Vault where the new CMK is stored, then it will just continue working.
Okay, so changing or rotating keys is not going to affect. You're not going to not be able to see the data,
right?
In there. So,
unless that's the intent, right? But yeah, if you correctly manage your access policies and make sure that your application still has access to the new CMK, so the post-rotation CMK is still available from the application, then yeah, there should be no impact.
Hey, another question from a viewer here. Can you encrypt the partition key?
So the answer is no, because you can't do it. The partition key is really a core concept in Cosmos DB that is used extensively for different things, mostly for horizontal scaling. And so today the encryption of the partition key itself is not supported.
Yeah, that would, and also if you randomize, I don't know how we'd even figure that out.
Right. I mean, this would have very deep impacts in the way we hash the partition key, and we use that hash in order to distribute the data over the partitions. Yeah.
Makes sense.
Yeah. Okay, back to my sample. So now that I have created my I have created my 2 employees here with encrypted data. I can go ahead and try to read back data. And so first, I'm going to fetch a single employee by ID, just doing that point read as I would usually do. Okay, and then I am outputting that thing on the console. Let me bring the console here. There we go. As you can see, my salary and my social security number are completely transparently decrypted and returned in their plaintext format. So I didn't have anything special to do. Because my application has access to the corresponding keys, we just went ahead and decrypt the keys transparently. Decrypt the properties transparently when the documents came back from the service.
Yeah, cool.
Yeah. Same goes if I want to issue a query, as I showed before. So I'm going to create a new query. I'm going to inject the value I want to filter on for the SSM. And then I'm just going to run the query, output the first result coming back. Oops, where is it? There we go. And here is my second employee with the SSN matching the SSN I was filtering now. So pretty straightforward. I mean, there is a bit of ceremony involved in initially creating the container, creating the keys, setting up the encryption policy. And once this is done, the actual impact on your application, on the code that you're using to read and write data, is very minimal. I mean, the only actual impact is here. If you want to filter on an encrypted property, there is some additional calls to inject the value. But other than that, reading, writing data is going to be exactly the same. Okay. So now, for the sake of completeness, let's look at my second program, and that program shows what the HR staff would do. Okay? So what I do here, I am initializing my Cosmos client in the exact same way as before. The only difference is that instead of using the identity of my HR service, I'm using the identity of my HR staff to initialize my Cosmos client. Okay? And so, if you remember, that identity only has access to the salary information, but not the SSN. Okay? So the first thing I'm trying to do here, I'm trying to just fetch all the employees as is. So I'm just going to do a select star from C and trying to just list me all the employees I have in my container. So let me start this. I'm going to start an instance here. Here we go. Okay, and well, there is a little suspense here because you have seen that I have actually wrapped that call in the try catch. So meaning that probably something is going to happen. So if I try to just run that query, and again the SDK has to warm a little bit at the beginning. Yeah, so I get an exception back, and why? The reason for that is because, well, my identity here, my HR staff identity, is not allowed to read the SSN, right? And so because my query here returns the SSN, which we know is an encrypted property because we have knowledge of the encryption policy, we can't disallow that, right? And this is actually a strong guarantee of always encrypted, is that only the data, the bits of data you are allowed to see will be returned to you, right? Yeah.
Why throw an exception though? Why not just show encrypted text?
We could. There are some complexities here. Is that if the user is strongly typing the return, then there may be mismatches between the encrypted version of the value, which is a string, I mean from a JSON perspective, and the original value that may be a number or an object or anything else. Right.
Interesting. So this is an implementation detail, but one that seems well thought out. In that if you're using the key with their connection here,
right,
and then grabbing any property that's not encrypted with that key, you're going to throw an exception. That's very interesting.
And again, that's a query that would be allowed to run in my other program, the program that was initialized with the HR service identity. That thing is allowed to see everything. So I could do a select star from C over there.
Is there a status code we return that user could use to, either handle that sort of exception, return something of an intelligent response to an end user saying, hey, sorry, this is encrypted and you don't have rights?
Yeah. So the exception is explicitly saying that. The exception is saying that you don't have access to key ABC. That's why we can't disallow the data and you can't see it.
Okay, so we're going to give them something that they can
absolutely
handle. So to either, I don't know how they would handle it, depends, I guess, but at least they can return something to the user that says you don't have the rights to see this. Okay.
That's right. And the workaround here, because obviously the HR staff needs to have access to the data, right? Maybe they don't care about the SSN, but they should be able to retrieve the rest. So the way to do that in our situation is just to project away the SSN. Okay? And so here I am running another query where I am explicitly projecting which properties I want to see. And so the SSN is not part of it because I'm not allowed to see that SSN. And so if I run that thing, do I have a breakpoint at the end? Yeah. I just iterate on the results, and there we go. Okay. The data has been decrypted accordingly.
In the exception that you would have returned prior, do we say what property it is that they can't access?
I believe so. So we are still iterating. We are, because we are still in the public preview, we are still iterating on the details of that exception. But again, the intent is to make it as actionable as possible. Yes.
Interesting. It would seem to me that that would be leaking secrets in itself, but
yeah,
you know what I'm saying.
Absolutely. Yeah, that's a good point.
Is, but we're ever going to tell you that it is salary that is throwing this is why you cannot see this. So I don't know.
Right.
Yeah.
No,
that'll be an interesting piece of user feedback. I'm sure.
Yeah, and something that we'll, as we usually do, that we assess with all the security teams we have in Azure, right? What are the best practices and what are things that actually could expose the secure data. If we are too verbose in the exception, that may not be something desirable. Keeping in mind that if you look at the encrypted data, so if I go back here to the data explorer, you can see that there is an SSN, right? So this is the data that anyone without any keys would see. If you just go to the data explorer, as I do here, you can see that there is an SSN, right? And so unless from the client side you have kind of obfuscated the property names into things that are more cryptic and less obvious, the property names are always there in plain text.
I guess you could do that, right? As a step, if you were uncomfortable exposing the fact that there is salary information in there, just obfuscate the name to something that only you understand, right? So that you're not leaking a potential secret. Right. It's like I used to see this like login services or something like that. Like somebody's trying to brute force like a password on a login, and you're like, oh, the password for that account is not correct. Oh, so you're saying there is an account there,
right? Yeah. And now I think the best practice is to say, for example, if you want to reset your password, you enter your email address, and they will tell you if there is a matching account, we have sent you an email.
That's correct.
They don't tell you that there is a matching account.
I don't see it. I see more and more, thankfully, doing it that way. So I got a question from a viewer here.
Yep.
Searching data using encrypted attributes, same RUs versus
yeah,
I would think so.
Yeah, it's the cost of matching a string, right?
I mean, you're right. I mean, the cost is, like you said earlier, is just going to be client side on the CPU.
That's right.
And whatever piece of compute is hosting your Cosmos client there. So
right.
Makes sense.
Until we introduce confidential computing and ways for our customers to run more elaborate queries in a more secure environment, this will probably come with different SKUs and slightly different pricing. I would imagine. We are still very, very early in those discussions, but this may have some kind of impact on the operations and the pricing of the service. But as of today, the pricing of the queries hasn't changed.
I guess too, if you're encrypting, at least if you're doing the randomized encryption type, no reason to index that, is there? Might as well explain that.
Yeah, absolutely. Yeah.
What's the point?
Absolutely.
So you're just chewing up index.
Yeah. I mean, the best practice of looking at your indexing policy and making sure that eventually you only index what you need, still applies, whether the data is encrypted or not. Yeah.
Very cool. You got some more to show us?
I think we are done. Let me see. I think where is my Visual Studio here? Yeah, that was the end of that demonstration. So hopefully that was clear enough to understand how we managed to implement that little use case where essentially anyone can read, the documents, but what we have done is that we have obfuscated salary and social security number behind encryption. So those things just look completely encrypted, and that's what you see if you just go to the Data Explorer and try to see what the data is in that container. Accessing those additional properties require you to have an access policy to the key vault containing the encryption key, and that's essentially how we have protected those properties behind encryption.
It's very cool. I love it. So this was great. I was really super excited when you showed me this on build, and now even more excited. I've got more. I'm falling behind on demos and but there's so many features we've pushed out.
Yeah,
I've got to go do I got to go build some RBAC demos using the new Azure Identity thing in there, because that is super cool.
It is.
And then start playing with that. I've got to create a demo around this stuff as well. So I've got more and more and more. So, and then of course, eventually you guys are going to come and ask me to write ARM templates and bicep and PowerShell and CLI samples around creating all this. That's going to be a heck of a lot of fun. So
you have a nice backlog of things.
I got a nice backlog. Yeah, you know what? I just finished porting all of our ARM template samples over to Bicep.
Cool.
So I've now got to get a docs page stood up for all the Bicep samples. But yeah, that took like 2 months. That was a lot of work.
I heard that more and more of our users are starting to use Bicep, so it's good for us to be updated.
Ahead of the curve on there. Yeah, I just basically decompiled the ARM templates in there. I mean, I cleaned them up a bit as well. So they're pretty straightforward. I like the Bicep. I mean, it's definitely less verbose and a little cleaner looking than, say, an ARM template is in there. So yeah, it's very cool. All right. Well, thank you, Thomas, so much. And folks, if you want to get started using the client-side encryption, I've got a docs link there. That'll take you to that page that Thomas was showing you earlier. Just got some announcements for you as well here. So we have started a new Cosmos DB user group. This is a completely online virtual user group. We're going to do monthly meetups starting in September. And I'm going to kick it off. I'm going to do a talk on modeling and partitioning in Cosmos DB. This was a talk actually initially developed by you, Thomas, that I've taken and kind of run with. I went and created a bunch of samples and demos and posted them into a GitHub repo.
Nice.
That you can go and run with, all in Visual Studio. Thomas's original session was all using our notebooks to do all the demos, but I went and created a Visual Studio project that goes through all the demos and shows kind of the evolution of the data model as it evolves from a SQL server relational data model over to a fully optimized NoSQL data model. Anyway, come join us. That's going to be our first user group meeting. Is going to be Wednesday, September 22nd at 2 p.m. Pacific time. That is, I believe, 10 p.m. In London. So BST. I think you're still on BST on the 22nd, or 7 a.m. Sydney, which is UTC plus 10 AEST, I believe, is their time zone there. So I know it's hard to find a good time for everyone. So for those of you there in London and Europe, join us with kind of maybe a late night cocktail nightcap. And then if you're in Sydney, how about maybe a glass of OJ or a coffee? And you can come and watch our user group meeting. We'll also do a giveaway for brand new Azure Cosmos DB neoprene coasters. So I've made some swag, and we'll give 1 or 2 of these away to a lucky user at our user group meeting. So anyway, link there at the bottom takes you to the meetup page. You can go and join, and then add a reminder for our first user group meetup September 22nd. And then next up is we're organizing a very first Azure Serverless Conf. So the Azure Cosmos DB team is teaming up with the Azure Functions folks, and as well as the SQL Server team, for the SQL Serverless folks over there, and Logic Apps. And we're going to run our very first online virtual online conference, Azure Serverless Conf. That'll be September 29th through 30th. It'll have a similar format to what we did for Cosmos DB Conf. So we'll have three 3-hour live streams, one in Americas, one in APAC, and one in EMEA. So you'll have a time zone friendly live stream. Each stream will have unique content with delivered by folks in your local time zone region. Basically, we have a CFP for this open now. You can see there's a link there for Sessionize. So if you're, say, an Azure or Microsoft MVP, or you give talks and you'd like to submit a session for Azure Serverless Conf, just feel free to follow that link there and submit a talk. All the sessions are 25 minutes in length, so it's kind of the same format we'll run. And we'll have a combination of live talks as well as on-demand available as well. So that's it for us this week. Next week, I've got special guest Andrew Liu. For those of you who know Andrew, he was one of the founding members on the PM team for Cosmos DB back when it was called Document DB. And next week, we're going to just have a conversation about kind of the history of Cosmos DB and kind of the history of NoSQL databases itself. And we'll just talk about how that kind of, Cosmos and NoSQL databases have kind of evolved over, the past decade or more. And then also get kind of a behind the scenes view as to how Cosmos is architected and built as well. So Andrew's going to whip out his whiteboard and do something of a kind of he's, I guess you could say, famous for this type of session. But he does a very fast, lightning fast kind of talk about how Cosmos DB is built, and he does it all on a whiteboard. So join us next week for Andrew and his whiteboard and our talk. I'll take one more question here, Thomas, for you before we go. Would it be possible to set up encryption policy by attributes in C# on a database model class? That's a good question.
That's an interesting one. Yeah, not something we have looked at. The way we have approached the encryption policy on Cosmos DB, at least, is to provide a model that is very similar to the indexing policy, right? Which is something that all existing Cosmos DB customers are probably familiar with. You define a policy with included path, and this takes the shape of basically a JSON document. Eventually, when you create that encryption policy through that Fluent API that I showed before, this is just formatting a JSON representation of the policy, and this is what's used in order to initialize the container. But that's actually a good idea that we should look at. We could probably provide either alternative ways of declaring the encryption policy, or maybe have those calls to the Fluent API being somehow automated by discovery of attributes.
It would be a step back almost from a SDK perspective, because if you recall, in our SDK v2, we had a document item or resource within there, and that you could extend that,
right,
and return and have documents kind of deserialized to that. You would almost need to do the same thing, with this, where you would have to have something of like a document resource, and then you would apply these attributes to it, if you will, for your POCO, and then there as you're modeling, you're creating a model,
right?
So.
And there is one thing that I haven't mentioned, and that I think that's important to highlight here, is that encryption policy is immutable, right? So at least in the current form of the feature, meaning that it is at the time of the creation of the container that you have to tell us, or rather tell the SDK, which are the JSON path that you want to encrypt and how you want to encrypt them and with which keys, etc. But once the container is created, there is no way, at least today, to update that, right? And so if we took the approach of actually discovering which properties you want to encrypt through attributes, we would have to deal, with situations where those attributes have changed, from one execution to the other. So probably other challenges down the road if we took that approach. Just by the sheer nature of the policy being immutable today. Yeah,
agreed.
Yeah.
Okay, well, Thomas, thank you so much. Great having you on again. And thank you, everyone, for joining us. And we'll see you next week with Andrew Liu. So thank you, everyone.
Thank you.
Bye-bye.
Bye.